Hey, good people. This is Arthur Morris. Welcome back. I hope that all is going well with you today. In this particular video, we are going to look at graphing exponential functions. All right, so the characteristics of an exponential function in the form of f of x equals b to the power of x is that your domain f of x equals b to the power of x. The domain consists of all real numbers from negative infinity to positive infinity. Now, this is before any translation. So if you have a plus or minus, or if the exponent is negative, then you know we have those translations that could change maybe your range, not necessarily your domain. So the range of f of x equals b to the power of x consists of all positive numbers from 0 to infinity. So we have a horizontal asymptote there of y equals 0. At the line y equals 0, we have a horizontal asymptote for that type of exponential function. All right, the graphs of all exponential functions of the form of f of x equals b to the power of x, they pass through the point 0, 1, because remember, anything to the power of 0 equals 1 and has a y-intercept of 1. If the base is greater than 1, then the graph goes up and to the right as it's increasing and gets steeper. If the base is between 0 and 1, so if it's a fraction or a decimal, then the graph goes down and to the left. It decreases. The function has to be 1 to 1, which means you should be able to test it with a horizontal line test and a vertical line test. And it approaches the x-axis but doesn't touch the x-axis. Just as we said, it has a horizontal asymptote of y equals 0, the line y equals 0. Okay, so let's look at some examples here. All right, so to graph this equation, f of x equals 1/4 to the power of x, let's make a table. So let's choose -1, 0, and 1 just for this particular graph. All right, so if I let x equal -1, then I have f of -1. Let's do it down here. 1/4 to the negative first power. So to remember, to make that exponent positive, that's the reciprocal property of those exponents. So that's the same thing as 4 to the positive power of 1, which equals 4. Now, what about if I let x equal 0? Well, that's 1/4 to the power of 0. And remember, anything raised to the power of 0 equals 1. That's right. And what about f of 1? 1/4 to the first power. Anything raised to the first power is just itself, so 1/4. All right, so keep it in mind, since I don't have a plus or minus anything after the 1/4 x to the first power, I have a horizontal asymptote of at y equals 0, or at the x-axis here. Let's plot these points. -1, 4, so -1 up 4, and then 0, 1, and then 1 and 1/4. So you can see that there's a steep decline, and this line will get closer and closer and closer to that x-axis, the x-axis, without touching it, because we have a horizontal asymptote at the x-axis, or at y equals 0. All right, let's look at another problem here. All right, so we have y equals 4 to the power of x. So again, make a table, an xy table. And you can use whatever you like to use. I'm going to use -1, 0, and 1 again. So this time, if I let x equal -1, then I have 4 to the negative first power, which again, using the reciprocal rule, that makes 1/4. Or if I have f to the power of 0, anything raised to the power of 0 is equal to 1. And f to the first power, anything raised to the first power is itself. All right, so let's graph these, and you'll see it's just the opposite of what we just had. So -1 and 1/4, 0 and 1, and 1 and 4. So this time, this thing increases and continues to increase and increase and increase. So we have a horizontal asymptote at y equals 0. You see that our domain is from -infinity to +infinity, and our range is from 0 to +infinity.